Hey, what is going on? I need to put on my hat today. Okay, and I have my coding hat on. Welcome to Shaft the Algo Man, all right, or Algo Guy. See, I'm changing my title again. Doesn't matter. Welcome to Shaft the Algo Guy. It is Thursday, May 26th, 2022, and we're hitting up the end of May. We're running up on the end of May, and boy, it has been a crazy May. Okay, and I don't mean only in the world. It's been crazy in the world. It's been crazy in all of our personal lives, I'm sure. It's been crazy for me in my career. And yeah, it's been crazy for me in my channel, especially since I have taken quite a few breaks from posting. Okay. No, I intend to get back to it. I just needed a pretty decent posting strategy. I needed to balance other things in my life and whatnot. So, yeah, with that being said, let's get back to it today. Thank you for watching my channel. If you like my stuff, like, subscribe, comment below in the comment section. And yeah, it again helps the algorithm, helps visibility for the channel, motivates me to help at putting these videos out there. There's plenty of coding videos out there, and I'm happy that you came and you're watching mine here. I'm truly grateful, and I hope that my explanations can help provide value to you. And obviously, there's good explanations all over the internets and YouTubes and etc. on these algorithms and these problems. So, feel free to use them in conjunction, or I'm just happy that you're here. Okay, so yeah, let's hit it right now. The problem that we're going to be doing today is Leetcode 128 longest consecutive sequence. Okay, and the problem statement is, oh, by the way, this is a what is known as the blind 75. Blind 75, if you don't know what that is, those are problems which are said, and I think the history is that they've been posted by somebody who got into somewhere into one of the things, and these blind 75 problems are basically a grouping of all the patterns you would need to pass a coding interview at a FANG. Okay, well, whatever the case is, I looked over the blind 75 and they're pretty challenging. And so at one point, I'm going to go over the blind 75 list. Okay, right now, though, this problem is on there, and there's many channels like Leetcode, etc., that have gone to great lengths to make these videos available for people to help them out, and that's awesome. But this problem is Leetcode 128, and it's a very early problem, and a lot of people have done it because, again, it's on the blind 75, and you can tell that it's liked quite a bit. Its ratio of likes to dislike is pretty high. Okay, so I'm gonna like it. I'm gonna also add it to my list of my favorites. And this problem statement is, given an unsorted array of integers nums, return the length of the longest consecutive element sequence. You must write an algorithm that runs in O of n time. Okay, so the input is 100, example input is 104, 201, 32, and just by looking at this, you can tell that the longest consecutive sequence is 1, 3, 4. 1, 2, 3, 4. Okay, and which is 4 elements long. Okay, and okay, intuitively, the reason why this is a popular problem is because this is one of those problems that the difference, it really shows your ability to kind of distinguish between fast and slow in terms of algorithmic operation. The slow brute force way of doing this, right? There's an n squared way of doing this, right? Which we can just look for numbers which happen to fall in a consecutive sequence into 4 loops, and it's something like this, and it'll be n squared, and it's a slow operation. Okay, and whenever you see some kind of n squared operation with an array, then you automatically want to think that there's potentially a better solution. Now, here's the deal. The key thing is this is an unsorted list, right? So what could we do? We could sort this list, and this would be a trivial solution. We could sort this list, and then we can just be like, okay, well, I'm going to just write the pseudocode here. For I less than I plus and nums of I less than nums of I plus 1 equals 1, then is consecutive consecutive equals true, and then if consecutive equals true, if I'm going to call it equals true, then what we do is I think I have this extra here. We in current plus 1 because we have this current sequence, and then longest equals math.max current and longest, and so that's how we would get the longest sequence. And so by doing this, and we do this in a for loop or while loop, right? So we could do this, and then we could just, the consecutive sequences of if you sort the array, the numbers are going to be lined up in their consecutive sequence order already. So that's the thing that that works, but it's O of n log n, right? O of n log n, which is not the most optimal way of doing this. Okay, all right. It's too simple, really, for one thing. And fangs and other, it wouldn't be on this list if it was that simple. Now now how else can we do this, right? Like, if you can't forcibly sort these numbers, right? How will you know that this answer that there is a faster algorithm? Okay, so for one thing, just giving you a little bit of a hint on this. First of all, we're going to have to do a trick. We're going to have to make a space-time trade-off, and which is something that's done in computer science a lot, is space-time trade-off, and you'll hear about people talking about space-time trade-offs, right? So let's just first get our longest value, and that's what we're going to return. We're going to return longest. This is the easy part, right? Now, what can we do in order to make sure that we how can we find the longest value? Okay, so take a look at this, okay? What do we know about consecutive sequences, right? How many consecutive sequences are there in this sequence? Okay, you have 100. I'm going to recopy and paste this sequence. How do we know we have a consecutive sequence? Well, the consecutive sequence, the sequence starts with a value, right? And what are the starting values of every sequence of numbers here that are consecutive? Well, there's 1, right? And then there's 100, right? Because 100 starts a whole new sequence of non-consecutive numbers. And then there's 200, okay? And obviously there's the rest of the sequence of numbers after 1. And 200 and 100 don't have anything after that. So how do we know that at this point we have, okay, that's great. First of all, how can we understand that? How can we get these starts of the sequences? It's a start to get the start. So how do we get the starts? All right, tongue-tied. Well, firstly, what do we know about the starting value? The starting value, right? The starting value in a consecutive sequence is always going to have a value after it, right? 1 is going to be followed by 2 is going to be followed by, but what else is there about this consecutive sequence that's true? Well, is there going to be a 0? No, right? In the 100, if we have a consecutive sequence, even though it's one element, it's starting with 100. What's true about this? Well, there is no 99 is not there, right? Okay, so we know that, and so what you can understand, 200 doesn't have 199. So you know that in order to find, you can find these consecutive sequence starts, right? If you find an element, if you're looking for them, and that element that you're looking for doesn't have a prior element. Okay, so how does that help us? Well, that can help us actually a lot. Firstly, I'm going to put all of these elements in a set, and this is where I was talking about that space-time trade-off. Okay, so for int I equals 0, I less than nums dot length I plus plus num set dot add. And I hope if you're watching this video, if you don't if you see better videos out there, which I guarantee there are, at least you're watching, and maybe you can treat this as some kind of ASMR. I'm, doubling as an ASMR voice actor just in case this algo guy thing doesn't work out. Okay, so listen to my algo coding if that makes you feel good. All right, so now I'm going to go through, I'm going to add these numbers to the set, and what does that do? Okay, well, that lets me quickly look up each of the numbers in the set. And what do I want to do? I want to check this set for each number if there's a num minus 1, right? Because if there's a num minus 1 in the set, then that element is not the start of a consecutive sequence. But if there isn't a num minus 1, then that is the start of a consecutive sequence, okay? Regardless if that sequence is only one element long, it is the start. So what can we do with this? If num set, I've added all my numbers to the set, right? And so all my numbers can be looked up in O of 1 time, constant time, right? If num set dot contains num minus 1, okay. All right, so I'm looking, remember, the reason I did that, and I hope this may start to become clear, the reason I put these elements all in a set is because I want to look up really fast whether there is a num minus 1 value in the set, okay? I can find this really fast. And think about this for a second if this doesn't immediately hit you. It will make sense. And so if that's the case, then I can start a new sequence. Okay, now what do I do? Now I can get the, now that I have all the num minus 1 values, what do I do with that, right? Because now I can get the value, I have the value 1, 200, I start on this value 1, 200, and 100, and 200, 1, 100, and 200. Okay, from this example, okay, all right? Now that I know the start, that still looks like that doesn't still let us line these elements up, does it? Well, actually we can. There is a way to line these elements up, and it's actually, the answer can be quite surprising, a little bit jarring, in fact. But if we, what do we know? Well, how can we get, if we know that we're at the start of a consecutive sequence of numbers, right? How can we get the other elements in this sequence, right? Without reorganizing the set. We can't reorganize the set. The set has no order. But what we can do is we can increment the number. For example, if I have 1, I know I know when I can find out when this consecutive sequence ends. How can I find it out? By adding 1 to 1 to make it 2, to make it 3, to make it 4, and then to make it 5. And if 5 doesn't exist in the set, right? If 5 doesn't exist in this set, then I know that the sequence is 4 elements long because it ended at 4, and which is the case. So I would have to essentially do another loop. Now, I know what some of you are thinking. Wait, this looks even worse, right? Why am I doing another internal nested loop inside this other loop, right? At this point, it looks like that the O of n log n operation is actually faster. But no, that's not the case, right? This is not going to be a quadratic, and you'll see what I mean. So what am I doing? Now I'm pretty much incrementing the length of the set. I'm incrementing, the number, right? So I can find the next consecutive sequence. Remember, it would be 1. As long as it contained nums, then I'll do num of 1, 2, 3, 4. And I'm incrementing this and checking in this loop for elements that are consecutive only if they exist in the set, right? So that's how I know these are actually consecutive elements of that set. And I'm also increasing the length of this set. That's like, I called it current length, okay? I created an element called current length. I initialized it to 0 because I'm going to have to do this for every consecutive set that exists. So I'm going to have to do this inner while loop at 1, 100, and 200. Okay? And luckily for 100 and 200, that while loop only goes once, but for 1, it will go 4 times. So it'll iterate 4 times. So now how does this help us? Well, okay. Well, we first have to, because again, is this as slow? This will help us find the consecutive elements, but why is this not as slow as the n squared operation, or why is it even faster to the n log n operation? Well, that's because we're only checking, and take some time to absorb this, we're only checking the number if it exists in the set, right? We're only checking for the presence of this number, this consecutive number in the set, and if it does exist, then we've gone past it and we're not checking it again, okay? In this outer loop, you're checking the number, we're checking all the keys of the set, and for all the keys of the set, we're simply just checking if for whenever a set start is found, if all the numbers are contained in that set, and we're doing the incrementing and check here, right, in the inner while loop. So, you know, if the sequence is longer, if there's only one, if the sequence is longer, right, you're only going to go through the sequence once externally, and then internally you'll go through the sequence all the way to the end of the sequence, and you know you'll already have found the longest consecutive number, right? You won't be, because let's say there won't be a need to loop. Like, this is only once will you have to loop 7 times. You won't have to loop 7 times for 2. You won't have to loop 7 times for 3. You won't have to loop 7 times for 4. You won't have to loop once for 99 and once for 100. But it's not quadratic, because the longer the consecutive sequence in a finite set of elements, the less iterations across the entire elements set you have to do, because the additional iteration positions are taken up by the consecutive elements, okay? So think about that for a bit, but that's essentially how you solve this. That's the logic of how this problem is fast. So now we have this current length, and why do I have current length? Because after we increment the current set, then we check which is the longest. Math.max equals longest current length. Okay. And we're done, right? Well, let's see. Set integer. Can I find num set? Oh, I always do this. Num set. I'm gonna definitely have one more. Yep, I knew it. Current length. Let's see. Cannot find symbol current length. Current length. What are you talking about? That symbol is right here. Ah, okay, that's right. You have to take current length. You have to do this longest check inside this if right after the while loop is done. Okay. And we run the code, and we get 4. And there you go, there's the answer. And there's ways of optimizing this, obviously, et cetera, but upper bounds wise, from a computational perspective, this would be an O of n operation, and O of n operation in speed, and O of n in space, because we're storing all the elements in an additional set. We're taking out the elements from the array, input array, and adding to the additional set. Okay, so that's it. If you like this video, like, subscribe, and yeah, like I said before, thank you for watching. I appreciate it, and I'll check you out later.